In a previous video, we've looked at these graphs. This is y is equal to 1 over x squared. This is y is equal to 1 over x. And we explored what's the limit as x approaches 0 in either of those scenarios. And in this left scenario, we saw as x becomes less and less negative, as it approaches 0 from the left-hand side, the value of 1 over x squared is unbounded in the positive direction. And the same thing happens as we approach x from the right. As we become less and less positive, but we are still positive, the value of 1 over x squared becomes unbounded in the positive direction. So in that video, we just said, hey, one could say that this limit is unbounded. But what we're going to do in this video is introduce new notation. Instead of just saying it's unbounded, we could say, hey, from both the left and the right, it looks like we're going to positive infinity. So we can introduce this notation of saying, hey, this is going to infinity, which you will sometimes see used. Some people would call this unbounded. Some people say it does not exist because it's not approaching some finite value, while some people will use this notation of the limit going to infinity. But what about this scenario? Can we use our new notation here? Well, when we approach 0 from the left, it looks like we're unbounded in the negative direction. And when we approach 0 from the right, we're unbounded in the positive direction. So here, you still could not say that the limit is approaching infinity because from the right, it's approaching infinity, but from the left, it's approaching negative infinity. So you would still say that this does not exist. You could do one-sided limits here, which if you're not familiar with, I encourage you to review it on Khan Academy. If you said the limit of 1 over x as x approaches 0 from the left-hand side, from values less than 0, well, then you would look at this right over here and say, well, look, it looks like we're going unbounded in the negative direction. So you would say this is equal to negative infinity. And of course, if you said the limit as x approaches 0 from the right of 1 over x, well, here you're unbounded in the positive direction, so that's going to be equal to positive infinity. Let's do an example problem from Khan Academy based on this idea and this notation. So here it says, consider graphs A, B, and C. The dashed lines represent asymptotes. Which of the graphs agree with this statement that the limit as x approaches 1 of h of x is equal to infinity? Pause this video and see if you can figure it out. All right, let's go through each of these. So we want to think about what happens at x equals 1. So that's right over here on graph A. So as we approach x equals 1, so let me write this. So the limit, let me do this for the different graphs. So for graph A, the limit as x approaches 1 from the left, that looks like it's unbounded in the positive direction. That equals infinity. And the limit as x approaches 1 from the right, well, that looks like it's going to negative infinity. That equals negative infinity. And since these are going in two different directions, you wouldn't be able to say that the limit as x approaches 1 from both directions is equal to infinity. So I would rule this one out. Now let's look at choice B. What's the limit as x approaches 1 from the left? And of course, these are of h of x. Got to write that down. So of h of x right over here. Well, as we approach from the left, we are going to, looks like we're going to positive infinity. And it looks like the limit of h of x as we approach 1 from the right is also going to positive infinity. And so since we're approaching, you could say, the same direction of infinity, you could say this for B. So B meets the constraints, but let's just check C to make sure. Well, you can see very clearly, x equals 1, that as we approach it from the left, we go to negative infinity, and as we approach from the right, we go to positive infinity. So this, once again, would not be approaching the same infinity, so you would rule this one out as well.